Hello, and welcome to part 2 of our Acceleration Mathematics video series. I am so glad to be back with you today. My name is Mary Davis, and I am a Hub Improvement Facilitator with Texas NSI, and I work with the Charles A. Dana Center at the University of Texas at Austin. Just a quick reminder, or maybe you started on video too, who knows? But just a quick reminder that these videos are to help give real life working strategies that you can take back and use in your classroom as soon as this afternoon to help you work from getting from remediation, which is just that drill and kill and remediate and look back without ever looking at the on grade level. And we're moving away from that and towards acceleration, which is, yes, we need to review them, but we want to review them while we are still working on grade level material. So it's that just-in-time remediation. So that's more on the acceleration. So I'm really excited to be here with you today because our part 2 of this series is all about visual aids and how they can help students organize and understand the material. So with that, as I said in video 1, that the first outcome is not going to change. It's really the goal of the whole series, and that is to solidify an understanding of what scaffolding really is and its role as we move towards this acceleration process. But today we're going to gain an understanding of how visual aids can be used to support acceleration in the mathematics classroom. So as usual, when we do video sessions instead of in person, instead of having norms, we simply have these 3 community agreements. The first one, come as you are. You could be anywhere. I could give this to someone who is currently visiting the moon and they would be able to watch it and learn from it. So wherever you are, that's great. But the whole idea is that you need to kind of close out the life around you. And I know that's always not easy to do, but we really want you to focus on the learning today. So come as you are, but learn what we've got. Second one, learning is iterative, meaning that it's cyclical in nature, just like our PDSA cycles. It's not going to happen in one sitting. You may have to watch the video over again. You may need to talk to friends. You may need to try one out in the classroom, see how it works. So there's a lot that you can do, but you're going to have to take baby steps in order to get this all into your normal routine. And then finally, embrace the pause. There's going to be sometimes that I tell you to pause, and then there's going to be other times that you just might want to stop and look at something more deeply than what I've given you time for, and that's fine. That's what those pause buttons are developed for. So please embrace the pause, reflect as much as you need to, return whenever you need to, and we'll make this work together. So a little bit more learning about scaffolding. I want you to think about this. Now I'm going to read it a couple times because every time I read it, I always get tongue-tied, so I apologize. But when students unfinished learning, and that's what we're going to call it, not gaps, these are opportunities to learn things. So when students unfinished learning does not prevent them from engaging with grade level content. All right. That means, yes, we know that we had COVID. Yes, we know that some kids were out of school for extended periods of time. Yes, we know that there were a lot of issues. There always are. Folks, this isn't new. This is not new. This is just a bigger scale. All right. So when this unfinished learning doesn't prevent them from being in the classroom and engaging with grade level content, that's when these scaffoldings come in. Because it's through these scaffolding that we meet them where they are in real time and give them what they need in real time. So it helps motivate them. Folks, there is nothing worse. There is nothing worse. I had a nephew that lived with me for a while, and when he went to college, he had to take remedial math courses, not because he necessarily needed them, but because he didn't take the tests seriously that he went to take. And so he had to sit in a class and just literally do stuff that he has done for years and years. It was not motivating. It was not something he wanted to do. It was not, in any way, shape, or form helping him. So what we need to do instead is to realize that there are some unfinished learning opportunities in there. And I do call them opportunities, because when we come across them, when we stumble across and we find out that somebody doesn't understand what the difference between a positive 2 and a negative 2 is, then instead of remediating them for a week on positive and negative numbers, we simply give them a couple of examples. We give them a strategy like we're going to talk about today, a visual aid strategy that might be able to help them or give them something to look back on. We might engage them in a number talk like we talked about last time, where we can really find out where that opportunity lies. Where did it fall apart? But we don't just go back and start from scratch. All right. We want them to believe in themselves. So mindset during acceleration. This is from Farrington in 2013. So it's a little bit farther back. This is not something that arose from the COVID pandemic or anything, but I'm going to give you a chance to read this, so you can pause it if you need to, but please read this to yourselves. Folks, mindset is probably the most important piece of the puzzle for teachers and for students. Okay. Or I guess I should have said that backwards, because we're talking about students. So for students and for teachers, but we have to realize that that sense of belonging, that sense of community, you've got to build that in your classroom. You've got to let them know that you believe in them. I've met a lot of teachers this year that I've worked with in the past, and I'm not just talking about NSI. So for those of you that are sitting in Crowley going, she's talking about us. No, maybe, but no. I've met a lot of teachers this year that have always had this fantastic mindset about the kids. And after 2.5 years of this situation that we have been forced to be part of. Yes, we're virtual. No, we're in person. No, we're virtual. We're in person. We can be 6 feet from each other, all that good stuff. Even some of the best teachers and the most positive students have started to get more negative mindsets. We need to turn that around, because if a student does not feel like they belong in that classroom, they aren't going to try. They're not going to stick with it. If they don't think you believe in them, then they don't believe in themselves. Why should they? Okay, so it's more important than ever with this situation. And because of the scale that it's at, like I said earlier, we've always had folks that, well, they went to mom and dad's, they go back and forth between homes, or I taught in San Antonio, and we had a lot of students that had family members that were in Mexico. And so they had to go back to Mexico and then come back. And so, learning was broken up. But that was only a few kids each year. Now it's like most of the kids. So we need to really build that belonging, that community in the classroom, to make sure that they will persist in the math, which is what we want them to do, that they're motivated to work and they want to learn. Here's another one. He continued his research. I will tell you that it is my belief, and this is the belief of Mary Davis, from the years that I was in the classroom, and it's research based as well, but a student that has been constantly, year after year, remediated, you don't know this, you can't do this, you're in a remediation class. I had to teach a class called repeater algebra. That was on their report cards, folks. Repeater algebra. How can kids feel like they're going to be successful if they're constantly, given that you're not going to do it? Sit over here, work on your times tables, whatever. All right. That's where that motivation comes in. That's where the academic behavior goes down. So today we're going to talk a lot about advanced organizers to keep these kids motivated and to make sure that they understand the material as it's presented. So when presenting a lot of information that could overwhelm the students, advanced organizers, this is our first type of visual aids, advanced organizers can help students understand, retain, and remember and use the material. Okay, you're going to recognize a lot of them. Sometimes we use them in our own PLCs, and you may have used them in classrooms before, but just want to go over it one more time. Remember that acceleration is all about identifying where students are at with their understanding and building off of that knowledge. So a lot of times visual aids can help with that. So here we go. The first advanced organizer we have is a Frair model. And a Frair model is all about, it's usually used in vocabulary. All right. I suppose it could be used in some other ways, but it was developed by a Frederick Frair to really talk about understanding the vocabulary. So the word goes in the middle. Then you write the definition in your own words. You write facts and characteristics of the word. You show examples and you show non-examples. The non-examples sometimes is the hardest part for kids. They're like, wait a minute, I can show you 3 examples, but what do you mean non-examples? So in your materials that are attached to this, you have a word copy of each of these visuals that we're going to talk about today. You have a PDF copy if you prefer to print a PDF out and have them write in it. And you have an example so that when you go back and you start to use them, you can see again how they're best used. So really quickly, I gotta go. Here's the PDF model. It's got 2 of the Frair models, 2 templates. So if you wanted some of the ways that you could use this, you could create your word walls with it. You could have the students create glossaries in their notebooks so they can look back on it. You could have them fill out one together with a partner so that the top one is their own and then the bottom one is after they've talked to other people and gotten more information about it. There's a lot of different ways that you can approach it, but the whole idea behind it is that they get enough information that they can use different senses to remember it. So they sometimes people even use a picture on it. So here's the example that's in your work with you or in the materials with you. So the example that I gave is the word equation. So of course, the definition and you can have them take the definition directly off like the internet or in a book, but you might want them to put it into their own words as well. So then there's some facts and characteristics about it, some examples, and then some non-examples. So that's just one example of a Frair model. Okay, know I have a. There we go. Sorry about that. Yeah, I had to have so many things open to show you guys all this cool stuff. So that's the first one. Now, the second one, you're going to probably have seen more in trainings, because a lot of times when you're sitting in a PLC meeting or something, we'll talk about, well, what do you know about acceleration? What would you like to know? And then at the end, what have you learned? So it has that reflection piece built in. But, you know, it's something that you can use with your students as well. And again, you will be given a PDF version and a Word document. So if you want them to use it on the computer. So this is just an example of one. I'm just going to keep going back and forth. I know it's kind of confusing. I'm sorry. But I want to show you the examples that are provided for you. On a KWL chart, the learning target, circumference, and areas of circles. So you guys write your learning targets and then brainstorm what the kids know about it. Now you can do this as a class, a whole classroom. You can do it as individuals. You can do it in groups, but the whole idea is to pull out that previous knowledge and to figure out exactly what it is that they want to know about it. So you can see this is in their own words. What is that pi thingy? And why do we only use it for circles? And so then at the end, what did you learn? And they can put that in there as well. Again, that's just a real built-in reflection tool that's really interesting when you're working with the KWL charts. So then we go on to concept developers, comparing and contrasting. And the Venn diagram has been around forever, and the kids are used to it in English class, and you may have used it in math class before, but you could use it in geometry is my example that I have to show for you. So the example here is the Venn diagram of comparing different shapes. And so everything in the left circle has right angles in it. Everything in the right circle are triangles. And so then, of course, the one in the middle has both the triangles and the right angle. So it's a right triangle. Okay. So that's just a very easy explanation of one that you could use, and it's not a lot of words in there. You could also do things like, I know that in middle school, they talk about things like, when is it proportional? When is it not proportional? That could be used in something like this. You could also do something like the difference between linear equations and other equations so that you can know what a linear equation looks like. These are all great ways to do this. I have seen this used in like a whole group setting that they put it on the wall. And then as they learn more about things, they add, is that on this side? Is that on that side? Is that, you know, both of them? And they continually add it as they work through it. So another way that you could possibly use it. The other compare and contrast example that I have for you is a compare and contrast matrix. And I just realized I turned off the screen. That wasn't good. So anyway, compare and contrast matrix is one that you can have different characteristics across the top and different items down the side. And then it's kind of a checkoff thing. So in this case, we're talking about quadrilaterals. And so opposite sides are parallel. Well, that's true for everything except for a kite. Opposite sides are congruent. And so you can see all the different pieces. And so then that's a whole lot of learning in one page that the students can use to refer to as they work through the quadrilateral discussion. This one, again, as you work through, you could give this blank to them as you begin talking about the characteristics. And then every day you can have them add to it so that it's finally a completed matrix at the end. So then they're ready for their test with it or quiz or whatever, so they can review. Another way to use this one. So trying to give you some different strategies there. Let's go back to the PowerPoint because we're done with the concept developers and we're moving on to sequencing and evaluating. Now, these are still under these are still under the concept developers, but they're no longer compare and contrast. These are ways for students to get their organization in their head straight and onto paper. Some of you use different problem solving models already, and those work great, and they would be in this category as well. Others of you don't use that, and kids sometimes get a little bit confused as they work through a problem. So you might want to consider some of these. I picked 3 very simple ones, and I did so on purpose because I wanted to make sure that the students could use it if they were taking like the STAR test or another big test. It would be easy for them to recreate it on their paper. So that's the reason that I chose very easy ones. So the first one is the diamond progression. And again, here's the example, but again, with these, just like the others, you will have a blank Word doc, a blank PDF provided for you, but I wanted to give you an example. So in this one, the middle is what do you need to find? And this is the volume of a cylinder. So what do you already know? To find the volume of a prism. So with a cylinder, it's pretty much the same, but it has a circular base. So then you brainstorm and you plan. So anyway, it's got all the different areas to help them think through things. So one way that you can do it. This is also a great way you could do a ticket at the door with a diamond progression. Put a problem in the middle here, what you already know, brainstorm, plan, solve it. And that can get you more information from them versus simply asking them to do a problem. It pulls out that language, that discussion onto paper. So very interesting suggestion. Then we have this is a very simple problem solving, steps to problem solving. It seriously has just the problem at the top. I've picked a release STAR test question. Then on the left, you put your attempted solution. On the right, what the results are, and then a conclusion. So basically you test it or you look for reasonableness or whatever, but it's just here's the problem. We need to solve it. We need to figure out what the results are, check it to make sure that that's what we were looking for, and then make sure it's reasonable. So very straightforward, very simple steps to problem solving. Again, some of you may already have different versions of that. The last one I think is kind of fun for a couple of reasons. Number one, our test is called the STAR, and this is a STAR sequence. But it also is kind of cool because it's arrows that make a star in the middle, and the kids kind of like it. And they like to create it. So they might actually draw it on their paper to do it. So here's a sample STAR question. And then what you do is you put a little bit of information in each one of the arrows that point towards the center. And then the center, you take all that information and you solve the problem. So again, just another way to get the kids to pull the information out of the problem and then to solve the problem. So So that's the end of the visual aids that I have to actually give you, but I do want to remind you of the manipulatives that you can use in the classroom. There's a lot of reasons why people don't use manipulatives, and we're going to talk about those here in just a second, but there's so many more reasons why you should use manipulatives, because that conceptual understanding, the reasons why things work, sticks with kids a lot longer than just doing the math. Okay, it sticks with them longer. So I want to give you some research behind it, so that you know I'm just not making this stuff up off the top of my head. But Hedens, Picotto, and Sebesta and Martin did a research project and had, with long-term use of manipulatives in mathematics, they found out that students make great gains in the following areas. The first one is verbalizing mathematical thinking. All right, because they show it with manipulatives, but they have to verbalize what it is they did with those manipulatives. They discuss mathematical ideas and concepts. They are able to relate a real world situation to the symbols. They work collaboratively better. They think divergently, so it's not just a one way to solve a problem. They express problems and solutions using a variety of mathematical symbols. They make presentations better because they're able to actually show and talk about things. And they take ownership of their learning experience. Those are all things we want students to know and be able to do. So it's that idea of moving from concrete to abstract. Whoops, sorry. I went too fast. So in the concrete level, the concept is introduced with manipulatives. The abstract is when we just use the symbols. And too often we jump to that before we do the manipulatives, the pictures, and then the abstract. So we need to, mentally, the kids need to move from concrete to representational to abstract. So I want you to pause and reflect for just a moment about the statement and these two questions. All right, thanks for pausing and thinking about that. The quote comes from Joe Bowler. I didn't put her name on there on purpose because a lot of people love, or they say that they love her, and they just kind of breeze past. But it's really important, as she points out here, that they have this creativity, this openness, visualization, and flexibility within their mathematics. So so what is it, do you think, that makes these concepts, sorry, I keep hitting the button too fast, that makes these visual developers, that helps mathematics come alive? And how does mathematics coming to life relate to acceleration? Well, students that are in this acceleration program have oftentimes been remediated for years. And if not, our last year of the pandemic has everyone feeling unsuccessful. So getting students to appreciate the joy in mathematics again, and to learn that unfinished learning is not forever, is what we really need. So think about that as you move forward in your work. So today's outcomes, just want to go back through. I know it was very fast, so this is one that you may want to go back and look at all these things that I handed to you, but looked at a lot of different visual aids that can be used to support acceleration. We thought about mindset in acceleration, and how bringing the joy of mathematics is an important piece of the acceleration process. Please join us again. Number Talks was session 1. We also have 2 other sessions, error detection and correction and collaborative placemats, that I hope you will join us for. Do not log off yet. I just want to give you a chance to get these emails down if you need assistance with visual aids or any other math related query. I'm available for Crowley ISD, and Jackie and Mike are available for Richardson ISD. Those are your Longhorn, UT, Dana Center contacts. And so finally, please take a moment to answer. It's just a few quick questions. It's the same one every time. Just make sure that you check that this is session 2 on visual aids. And you can leave this on the screen as long as you need it. And with that, thank you very much for joining us today.